Jioni safu nola with whatever we do. Hale yidemu new school. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke nungoto ni beti sola. Ibuloke dato ni betoto.
Bengi Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kabana wulo kono.
Wulo kono nyinte mo Lamin.
Pabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Nunda mana.
Famo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani bana na mudu ma kontan.
Ngoto minaka ngala min je fon filitala. Lamin jibe nori nyaala.
Lamin ida siran sama ne benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakkilo diata bake karamu ngoto. Anu santeng ministry ko di ngole si suko na amake ko do holi
si bitun.
Bagona ringa.
Ala ni ko kede namo balo
ala ni na ko na karta bulo be damla ala ni je.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu ne keda.
Ite Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala karango.
Jamani karamol be soron ne ko fasi ta wulo ko nako.
Karamol ma soron ni ko karamol soron da amake ko holiday lem. Ngoto. Dini wonyanta sila la ala karango la moy yamen kaben fue. Man kontan andamande.
Allah min kombo courant adanda la kombo len do la jan karamol le soron do kabe courant ma do la kombo. E don do fanena karamol soron je karamol soron Lamin adara lo ni no la man tara fe na sokon. Ala mu nekela
Lamin ite fete malon ko lesino de ke radio to.
Nga fine.
E ko yaadi mo Lamin.
Nga fine.
Ya mo na fonye.
Kabe mina kan tambita nteri maning Fatu. Tambite la sukala ala dinngol bebe siri be la moyka.
Faru danso am fana tambita jere ni subala la ngaje dinngol be jet talanta nen kili warol. E be seri jelet.
Sa Lamin farante ku kili woke no la ba Lamin bitaka wulo ko no nyinta mo arami.
Aman dara fenela.
Ite dide ko ni man si yakari lesino la moy radio to balon na.
Mo ne ka ke afenye ba nyaara ni alon.
Kelentel jikot.
Afenye ba mo de be ke.
Ite balontel be jikritel. Ni man karambe ku kele. Yaje nata karana mbasa malaya ay tarije.
Par ñarande kombo courant ho findira kombo ide na raje ni sonka bay ko Lamin manya tala wulo ko karamo be so da fa ne membe
ko to wole nati bayo ngalle ni Lamin kuntala kombo courant e ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ile subjector baby jele baby jele
wala nan ka coco moy fa dan so wala ngombe tambi kana ngadi ngol de be ikadum bungo de be kala marmo
ma asototal de
Lamin mala be kara wala de
bari laftal ideal on ko inde every year second wala fourth
mona ni ko di ha ko de ko folle sinila ba ndele sinilo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fanam bulata ko ko don meyen nati jambi Lamin nyanta karana ntel beji ko be nyine ka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wala ka munda kara mo man so Lamin nyanta kara si so na radio
la sino le ayala le sino
dal ko korno ko smalo
kilar ya
be ngala ko momo sa mi do ni ko kara
nengi bruzo
am ndelo ko la da ba rosa no radio ba no bari woro radio ni abe je be baru ngamra do man dembe buljan ala nyara nyara woro ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya labi tamete
teku
bari ko do famo ke
ja image nani nyambol si zol le ke je kisgi man si zol no le kabun ka nyoma bari nyambu kino ni manya na ka finde ni nambe ko so la ga
ngalle limbeta de be nyambo do dilanna
nyara ni ko rin fenat nyara nata
bari famo ke da
nata bungono Kami bungono nyara ngando go fele ko ke bar nganda ni pelo la dija
iyo a
la bungono bismillah bisu diara
pendulala ye fongo tanka sina dulu tanka koro ta koro
Hello guys, my name is Yusuf Ajalo and I welcome you to my chemistry class. In our today's lesson, we'll begin by looking at the classification of organic compounds. Okay. Organic compounds are compounds of carbon. Okay. Carbon is one of the most abundant atoms found in nature, and carbon can form more compounds than any other atom, because carbon has the ability to form carbon-carbon single bonds. It can form carbon-carbon double bonds, carbon-carbon triple bonds. And also, carbon can form bonds with other atoms, like you can have carbon-hydrogen bond, you can have carbon-oxygen bond, carbon-nitrogen bond. Okay. And then a carbon-oxygen bond can be a double bond. A carbon-nitrogen bond can be a double bond, or it can be a triple bond. Okay? So carbon can form more compounds than any other atom. And we are going to look at how we classify organic compounds which are made up of carbon. Okay? And also, another thing to note here is that carbon has the ability to form 4 bonds. Why? Because it has 4 valence electrons. Okay. So therefore, it can form 4 covalent bonds. Okay. Let's look at the classification of organic compounds. Organic compounds can be classified based on their structures or functional group. Okay. We're going to look at these 2 ways of classifying organic compounds. Structural classification and functional group classification. So the first thing we're going to look at is structural way of classifying organic compounds. First, we can classify organic compounds either as what? Aliphatic compounds. And what are aliphatic compounds? These are organic compounds that are either straight chain or branch chain alkanes or alkynes. So basically, aliphatic hydrocarbons are made up of straight chain hydrocarbons or branch chain hydrocarbons. And they could either be an alkene or an alkane or an alkyne. For example, this is a straight chain hydrocarbon, and this is made up of carbon-carbon single bond. So this is an alkane. We can also have, if you have that carbon there, it can be referred as what? A branch chain hydrocarbon. And they are all single bond, so it's an alkane. You can also have an alkene, which can be a straight chain, a branch chain rather, or we can have an alkene, which is a straight chain. So compounds that looks like that, meaning compounds that are made up of either alkenes or alkynes, and then they are in the straight chain or branch chain, are referred to as aliphatic hydrocarbons. Okay. Another classification we'll consider here or we'll look at is alicyclic compounds. These are organic compounds that contain a hydrocarbon ring. Okay. So a hydrocarbon ring could look like that, or let me show the carbons. These 2 structures are the same, because here each of the corners represent what? A carbon. Okay. So this is in a ring form, and this type of hydrocarbons are referred to as alicyclic compounds. We can also have heterocyclic compounds. Okay. These are organic compounds that contains at least 1 heteroatom, an atom other than carbon and hydrogen in a closed ring. It's referred as a heteroatom. Now, for example, if you have a structure like this, this is a heterocyclic compound. Why? There is an atom which is not hydrogen and which is not carbon. And this atom here is oxygen. So if you have atoms like oxygen, nitrogen, or sulfur, in a ring, the compound is referred to as what? Or it is classified as an heterocyclic compound or a heterocyclic compound. Another structural classification we'll look at is aromatic compounds. These are organic compounds that contains a benzene ring. Okay? A benzene ring has 6 carbons and then 6 hydrogens. This is how a benzene ring looks like. It has 6 carbons, 1, 2, 3, 4, 5, 6, and then 6 hydrogens. Remember, carbon should always be surrounded by 4 bonds because it has 4 valence electrons, which we mentioned earlier, and each of these valence electrons will form a covalent bond. So therefore, this carbon will be surrounded by 1, 2, 3, 4 bonds. This as well will have a hydrogen, hydrogen, hydrogen. So you have 1, 2, 3, 4, 5, 6 carbons and then 6 hydrogen. And all aromatic compounds have benzene ring as their basic structure. You can have more than one benzene ring, but at least there should be one benzene ring. So this is how we classify organic compounds structurally. One is aliphatic compounds, which are straight or branching hydrocarbons. We can have alicyclic compounds, which are organic compounds that contains a hydrocarbon ring. Heterocyclic compounds, which are organic compounds that contains at least one heteroatom, that is an atom other than carbon and hydrogen in a closed ring. Or aromatic compounds, which are compounds that contains a benzene ring. Then we look at another method of classifying organic compounds. And this is functional group classification. Classifying organic compounds based on their functional group. But first, what is a functional group? Functional groups are atoms or groups of atoms in an organic molecule which are responsible for the chemical reactivity. So the chemical properties of an organic compound is characterized by the functional group, which could be either an atom or group of atoms. Note that alkanes are not considered to have a functional group, although reactions that can take place in alkanes is a replacement of what? An hydrogen atom. Okay. In general, hydrogen atoms of alkanes are relatively unreactive, and any other group attached to the hydrocarbon chain will be the functional group. Okay. So we have some functional groups here that we'll be going through in this course. We have the family names, the functional group structure, the simple example, and name ending, that is the suffix. Okay. So first of all, we have alkanes, which are carbon-carbon single bonds, and then a simple alkene, or an example of an alkane. A simple alkane is methane, which is CH4. We have 1 carbon and then 4 hydrogens. And then it has the suffix E, Ne. Another functional group we'll be looking at here is alkenes. Okay. Alkenes are characterized by carbon-carbon double bond. All organic compounds that contain at least 1 carbon-carbon double bond are referred to as alkenes. And then they have the suffix Ene. And then another functional group is alkynes. Alkynes are characterized by carbon-carbon triple bond. Okay. So any organic compound that contains at least 1 carbon-carbon triple bond will be referred to as an alkyne. And then they have the ending or suffix Y, N, E. And then the simplest alkyne is ethine. Another functional group is alkanols. Okay. Alkanols have the hydroxyl group, that is the OH group. So the OH functional group characterize alcohols. Okay. Generally, we can write it as ROH, where R represents the hydrocarbon chain. R can never be a hydrogen. If R becomes a hydrogen, then it's not an alcohol. Instead, it is what? Water. Okay. So this R group here is a hydrocarbon chain. And then alcohols have the suffix OL. And then the simplest alcohol is methanol. Another functional group is alkanoic acids. Okay. And acids have COOH as their functional group. Okay. Carbon bonded to 2 oxygen atoms. And then an R group. This R here in acids, this R can be a hydrogen and it can be a hydrocarbon chain. Okay. If it is a hydrogen, then we'll have the simplest acid, which is organic acid, which is methanoic acid. And then acids has the suffix OIC, then acid. Okay. All acids ends with this OIC, then acid. Okay. And we have another functional group which are referred to as alkanoids. And then alkanoids have COO as their functional group. Okay. The COO characterize the functional groups of what? Esters. So if you look at them, they are acid derivatives. They are derived from acids. So this can have an R group and then R group. So the R prime can be a hydrogen, but then the R double prime there cannot be a hydrogen. When it becomes a hydrogen, then it will be an acid instead of what? An ester. Okay. So generally, we can write the ester functional group like that. And then we can look at an example of an ester. A simple ester could look like this. And then they have the suffix OE, TE. And this will be called methyl methanoate. Another functional group is alkoxides. Okay. That's the oxygen family, where the R and then the R double prime, R prime and R double prime are all alkyl groups, meaning they are all hydrocarbon chain. Okay. So the oxygen is the functional group that characterizes what? Alkoxides. Okay. And then a simple alkoxide is a simple example of an alkoxide. They are also called ether, is methoxymethane, or you can call it dimethyl ether. So we either call them met, meaning 1 carbon, then oxy, the functional group, then methane, meaning 1 carbon, or we can call it as, since we have 2 alkyl groups, we can, and they are all the same, so we can call it dimethyl ether. So they have these 2 different ways of naming them. And finally, we look at the amine functional group, which is NH2. Okay. So the amine functional group has a nitrogen with 2 hydrogens bonded to it. And then the R group here is a hydrocarbon chain. Okay. And then we can have An example of this are CH3N2. Okay, and this is named as methyl amine. Okay. Methyl amine. Okay. So these are some functional groups that we will look at. Then we look at hydrocarbons. Hydrocarbons are compounds which contain only carbon and hydrogen atoms. So the basic structure of a hydrocarbon will look like that. Okay? Compounds that contains carbon and hydrogen. Aromatic hydrocarbons are also referred to as arenes. We can have these different forms of hydrocarbons. We can have aromatic hydrocarbons which are referred to as arene and contains one or more benzene ring. We've looked at a benzene ring before. A structure that looks like that is a benzene ring, where this is a carbon, 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 carbon. Okay. And then you also have the hydrogens there. Each carbon has one hydrogen. Okay. So all aromatic hydrocarbons have this ring, at least one of these rings. Okay. We can also have aliphatic hydrocarbons, which have what, straight chains or branch chains, and they are in three forms, which are alkanes, alkenes, and then alkynes. So the major sources of hydrocarbons. Okay. The major sources of hydrocarbons are natural gases, which is a gaseous fuel. You can also have what, petroleum or crude oil, a dark viscous liquid fuel, and then coal is another natural source of what, or major source of hydrocarbons. And coal is what, a solid fuel. Note that all hydrocarbons burn in excess air to produce carbon dioxide and water. Okay? And all hydrocarbons burn in limited air to produce carbon 2 oxide and water. In some cases, carbon is also produced in the form of what, soot. Let's look at this reaction between hydrocarbons, which we said are made up of carbon and hydrogen. Let's say, for example, we have CH4 reacting with oxygen. In excess air, that is excess oxygen, the product is carbon 4 oxide and water, or which is referred as carbon dioxide. Okay. But if it is limited air, that is limited oxygen, carbon monoxide or carbon 2 oxide is produced and water. And in some cases, carbon is also produced or soot. So next we're going to talk about the general properties of organic compounds. And one of these general properties we will talk about is homologous series. Homologous series are a group of structurally related substances in which successive members differ by a CH2 group. Okay? And the members of a homologous series are called homologous. What are the characteristics of what, homologous series? All members of this series conform to the same general molecular formula. Like, for example, if you look at this compound here, all of these compounds have something in common. Okay. From 1 to 2, you have a difference of 1 carbon. And then the difference in hydrogens is 2. So they are called homologs because the difference is CH2. And also between C2 and C3, if you look at the difference, is 1 carbon, and then 8 minus 6 hydrogens is going to be 2. Okay. So they all conform to the same general formula. That is CnH2n plus 2. Here C is 1, so that means N is going to be 1. So 1 times 2 is 2, plus 2, 4. So therefore, this carbon has 4 hydrogens. If you look at this structure as well, your N here is 2. 2 times 2 is 4. 4 plus 2, 6. So this as well conforms to that general formula. Yeah? If you look at this carbon as well, that carbon has 3 hydrogens, 3 carbons, meaning the N here is 3. 3 times 2, 6, plus 2, 8. So therefore, this compound as well conforms to this general formula. So this 1, 2, 3 compounds are referred to as homologs. Why? Because they are of the same general molecular formula. Okay. If you look at these compounds as well, they all conform to the same general formula, that is CnH2n. If you look at the first compound, first let's try to identify whether they are of the same homologous series. So we did mention that compounds of the same homologous series will differ by this, that is 1 carbon and 2 hydrogens. So if you look at C2 and C3 are in sequence, right? So therefore, the difference between the number of carbon is 1, and then the number of hydrogens is 6 and 4. So the difference is 2. So therefore, they can be referred to as homologs. And here, for the first one, N is 2. 2 times 2 is 4. So therefore, we have 4 hydrogens. It conforms to this general formula. In the second one, C is 3, meaning the number of N here is 3. And therefore, 2 times 3 is 6. 6 hydrogens we have. So it conforms to that general formula. The third example, or molecule, has 4 carbons. So your N becomes 4. 2 times 4 is 8. So they all conform to the same general formula. Therefore, they are referred to as homologs. So all members of the series conform to the same general molecular formula. Okay. And also, all members of the series differ from each successive member by CH2. Okay, we have confirmed that. We have confirmed that if you have the same homologous series, your difference is CH2. All members of the series show similar chemical properties. Why would they have the similar chemical properties? They are of the same functional group. So if you have the same functional group, you'll be of similar chemical properties. Okay? Because the functional group determines what? The chemical reactivity of a compound. And another properties or characteristics of homologous series is their physical properties differ along the series. Okay? Why would the physical properties differ? Is as a result of what? Difference in the number of carbons. Okay? So as the carbon chain increases, the physical properties also changes, like boiling points. As the number of carbons changes, the boiling point changes. As the number of carbons changes, the solubility as well changes. So compounds of the same homologous series could have different physical properties. Next, we will discuss about alkyl groups. An alkyl group is a hydrocarbon radical derived from an alkane by the removal of one hydrogen atom. They have a general formula, CN H2N plus 1, because one hydrogen is being removed. And then they have the suffix YL. So the YL replaces what? The ANE suffix from an alkane. Okay. For example, if you have this methane, this is an alkane and it has the suffix ANE. By removing one hydrogen, we'll have CH3. Okay? And CH3 is formed as a result of what? Removing a hydrogen from CH4. So therefore, this is referred to as an alkyl group. And then the ANE suffix from the alkene will be replaced by YL. So we'll name this as methyl. Okay. If you have another alkene which is made up of 2 carbons and it is called what? Ethene. If you should remove 1 hydrogen from either of the carbons, let's say we remove it from the second carbon from our left, we'll have 2 more hydrogens remaining. Yeah? And since there's a difference of 1 hydrogen, then we refer to this as an alkyl group. Okay? And then to name this alkyl group, we replace the ANE suffix from the ethane corresponding ethane and replace it by YL. So we'll have ethyl. Okay. So this is how alkyl groups are formed. Okay. They are formed when a hydrogen is being removed from an alkene. Next, we look at substituents. A substituent is any atom or group of atoms except hydrogen which is bonded to the longest continuous chain. So a substituent replaces 1 hydrogen in the carbon chain. For example, if you should have a carbon there, this carbon is not part of the longest hydrocarbon chain. So therefore, this is referred to as a substituent. Okay? Or if you should have should have a structure like this means the longest hydrocarbon chain, right? And this group here is not part of the longest hydrocarbon chain, and this atom here is not part of the longest hydrocarbon chain. So therefore, we refer to this as a substituent. And here as well, we refer to this as a substituent. Okay. So there are always, or there are species that always interrupt the longest hydrocarbon chain. So in naming organic compounds, we will consider substituents. Let's look at some sample questions. The first question reads, define the term functional group. Okay? Define the term functional group. So a functional group, we said, determines what the chemical reactivity of an organic compound. Okay? We have various functional groups, example, alcohols, alkenes, alkynes, acids, etc. Okay? And the functional group in alcohol is the OH. So the OH determines what type of reaction the compounds undergo. And the second question is, name the functional groups present in the following compounds. Okay, what are the functional groups here? We have to name them, right? So this is one of the functional groups. And this functional group here is a ketone. That is CO. Or we call them alkanones. Another functional group here is OH. So the OH are alkanols. And then we have another functional group here, which is COO, which are esters or alkanoids. And then the second structure so the second structure has a carbon-carbon double bond and then has COOH. So the carbon-carbon double bond is an alkene, and then the COOH is an alkanoic acid. And the second question is, list two characteristics of homologous series. Okay, they have the same general molecular formula, they have similar chemical properties, their physical properties differ, etc. And then the next to that is, what are hydrocarbons? Hydrocarbons are organic compounds that are made up of carbon and hydrogen. So you have to list two natural sources of hydrocarbons. Hydrocarbons can be obtained from petroleum, they can be obtained from crude oil, they can be obtained from coal, they can be obtained from natural gas. So you have to write an equation to show how ethane reacts when it bonds in limited air. How ethane reacts when it bonds in limited air. Ethane is when it bonds in limited air, the product is carbon monoxide and water. This brings us to the end of the lesson. Until we meet next, bye for now.